Hello and welcome for a new UniTFT Designer video tutorial. My name is Michael and I'm working for Electronic Assembly's development team.
Today's tutorial is designed to give an overview of array functions in the UniTFT series. A difference is made between numeric arrays and string arrays. We would like to start with the numeric ones. The UniTFT series offers both integer and float arrays. The register editor offers the possibility to create an array and already initialize it. Therefore, we select the array section and insert a new one. We give it a unique name. With this beautified name, we can access the array in the macros in future. The ID can also be set here. In the UniTFT series, up to 500 different arrays can be created. In the UniTFT S series, up to 200. Please note that both numeric and string arrays are in the same ID group. The properties of the array as well as the default values can be set with a double click on the default value area. The array editor opens. In the case of numeric arrays, you can first specify the type. You can choose between integer and float. In addition, the size of the array can be specified. We choose 10 entries. Finally, you can define the behavior of the array in case of an overflow. You can choose between stop at end and wrap around. In the first case, the right pointer stops at the end. If further values are now written to the array, they are ignored and not included in the array. In the other case, the end is wrapped and the array is written again from the beginning with the new values. The desired default values can now be entered in the table below. In addition, there are 3 filling options. For example, all table entries can be predefined with a default value. It is also possible to fill the table with random values. We select the range 0 to 100. In addition, there is the option to read in values from a CSV file. First, select the desired file. Another dialog opens. Here, you set the correct format of the CSV file and select the desired data. On the right side is a live preview of the table with selected settings. If I change the separator, for example, the preview of the table changes immediately. In our case, the semicolon was chosen as separator. If floating point numbers are used in the table, it is important to specify the separator for them as well. In our case, the comma was used as separator. Now we can select the desired data. We would like to integrate the second column into our table. You can also specify whether you want to import all rows. Alternatively, you can select the first and the last row. The data to be imported is highlighted in orange. The table has now been included in our editor. If we want that future changes in the CSV file are updated in the designer, select the option Link Table. In this case, no changes can be made to the array type and size. Let's take a look to the result in the simulator. In the menu item view, we select the entry Array Values. A window opens in which we can view 2 arrays at the same time. With the help of UniTFT commands, we can manipulate the array. In the following, I would like to discuss the most important ones and imply them to our array via the LZD terminal. All used commands can of course be used in macros. First, I start the LZD terminal via the menu file LZD terminal. I would like to start with the sorting function. With the command vqa variable quicksort array, the array entries can be sorted. This command only requires the ID of the array as parameter. After pressing the return key, the array is sorted. The value within the array can also be changed. For this purpose, we have 2 commands. I would like to start with the command vav. variable array value. This command needs the array ID, the index which should be written, and the value. We want to change the entry of the array index 4 to 5. The second way to change entries is via the right pointer. In our case, the right pointer is set to 0. First, we have to set the pointer to the desired position. We do this with the command VAP, variable array pointer. This command can be used to set both the right and the read pointer. If -1 is passed as pointer, it remains unchanged. The command expects the right pointer as a parameter in addition to the array ID. Optionally, the read pointer can be specified as a further parameter. We select 4 as new right pointer. Now we can change the value with the command VAW, variable array right. We only need the array ID and the desired value, in our case 7. Finally, I would like to mention the possibility of deleting the whole array. This is done with the command VAD, variable array delete. Besides commands for manipulating arrays, there are numerous calculations. With these functions, you have, for example, access to each content of the array or the location of the write or read pointer. First, we want to output the current write and read pointer. For this, we use a formatted text. We drag and drop a text element onto the screen. We change the text type to formatted text and edit it by double-clicking. We need 2 decimal values. In the parameter field, we specify the necessary calculations. The current write pointer is returned with the function array_write pointer, the read pointer with array_read pointer. Both calculations need the array ID as index, in our case 1. Let's take a look to the result in the simulator. As expected, we get the value 0 as write and 0 as read pointer. Next, we want to specify values from the array. Similar to changing the values by command, there are 2 options for the calculation functions. For the output, we again place a formatted text and edit it by double-clicking. The first option is to return an array value with an index specified. Therefore, we need the calculation RV. In addition to the ID, it also requires the index as a parameter. We choose 5. The second option is using the read pointer. The function is the same, only without the second parameter. Again, we take a look to the result in the simulator. Both values are output correctly. The read pointer is automatically incremented by 1. Finally, we consider the possibility of statistical analysis. We output the minimum and maximum value as well as the sum and mean value. For this, we also place a formatted text. The necessary calculation functions are array min, array max, array sum, and array average. Once again, we look at the result on the simulator. Now, the calculated values minimum, maximum, sum, and average are also output. Next, we come to the string arrays. In the register editor, we now create a string array and give it a new name. As with numeric arrays, we can edit the array by double-clicking. The Familiar editor opens. Here, we can specify the array size and the end type as well. Additionally, we have to define the string length. It specifies the maximum length of each string in an array. It is also possible to calculate the length automatically. For this, all strings are considered which are using during initialization. In addition to the direct input in the table, the option of importing from a CSV file is also available. We select this option. An import dialog opens again. Again, we select the second column. The well-known array manipulations can also be applied to the string arrays. Since the calculations can only return numeric values, accessing individual array entries is slightly different for string arrays. As an example, we want to write the first entry of the array into the string register 0. Therefore, we go to the screen initialization. We need the command VSS, variable string register set. We want to write our result into the register 0. We get access to the string array with the key A, with the correct ID, in our case 0. Finally, we need the index. This is specified with the key E and the respective index. We want to write the first entry into the string register. Therefore, we use the index 0. Let's have a look to the result in the simulator. We can now see that in addition to array 1, array 0 has also been filled with values. Via the menu View Register Values, we open the dialog to view the registers as well. We can see that string register 0 contains the correct first array entry.
I hope you enjoyed today's UnityFT video tutorial. Maybe you have time and play around a little bit with our sample projects and enjoy our other tutorials.